Okay, welcome to a new week of lectures. We will be having 3 lectures this week, and we will be talking about more detailed object-oriented design and the grasp patterns for this week. So there will be a lot of designing, coding, testing, coding, designing, testing in some kind of order. First of all, you have finished the first workshop, and the deadline was yesterday. And we have got a number of submissions. 2 things to think about. Make sure your portfolio link is open for access. Some links seems to be closed for access, and it takes a lot of time to request access and some kind of waiting period and get some kind of response back. So if you're using Google Drive or something like that, make sure you open up the folder or document you want us to take a look at to avoid unnecessary delays. And also, some of you have missed the step 6 and 7 in the peer review process. You should save the peer reviews you have written in your portfolio, and you should save the peer review protocols you received in your portfolio. In some portfolios, we find nothing. And if we find nothing, we can't pass you. So, but you will get an email about this, but if you know that, oh, we forgot that, add them as soon as possible. Questions on that? But this is the general way it will work now. We will add the workshop 2, first submission, peer review, final submission. So that is how it will work. I've looked through a number of reviews, and of course there are both good and bad. My general impression is that this year the reviews are better than last year, and also you have been forced to take a look at some literature doing the reviews, and I think this has in many cases made the quality better in the reviews. So that is a good thing, I think. I think that was a good change for this year. Of course, if you did not get any reviews sent to you, you can't add them to your portfolio, so that is something to think about also. Questions on the procedures for the workshops? Because you will be doing this for the second workshop also and for the third one. All right. So, workshop 1 done. Hopefully you will pass. I hope to make the examination done on Wednesday or something like that. So it will be fairly quick, and then I will send emails to all the group responsibles with the result. Maybe some quick feedback, depending. If everything is A-OK, you will probably not get that much more than good work. If I have something to say, well, you will get that also. But more specifically, I will post a solution for the first workshop later this week. So you can take a look at my suggested solution and compare it to your own, and you can read a little bit about how I thought about this problem and compare it to your own model. Domain modeling is of course hard because there is no really objective way of saying this is right and this is wrong. We have these guidelines and you can abide by them more or less, of course. But I will be posting my suggested solution, and you can take a look at that and learn a little bit more. But the first workshop is actually quite small, especially compared to the second workshop. This is the bulk of the course. So I really, really recommend that you take a look at it as soon as possible. Start thinking about it. And we have next week as the workshop week with introductions at the start of the week and tutoring towards the end. And it is fine to come with questions during the introduction also. So prepare as much as possible, and we can take any questions in the introduction so that you have a flying start, so that you don't sit down and start with the workshop on Monday or Tuesday, because this is quite a massive amount of work you need to do. Especially if you have a hard time programming. Anyway, the workshop is well, basically a simple member registry with basic functionalities and some requirements you should abide to. Yeah, and the process will be the same. You will do this, you will send in before the deadline, you will peer review, and you will make changes and do a final submission. There will be a little bit more time allocated also to this workshop in the deadlines. But this is a massive workshop. Start with it early. I also recommend that you do something simple for the user interface. A console application will absolutely do, no problems. I don't really recommend you doing anything web-based because that will be messier for you. But the choice is up to you. If you do something in a very strange language or something like that, also be prepared to get maybe a little bit, it's harder to get good feedback from the peer review group, of course, because they are not used to that programming language, and well, such is it. And avoid, in my opinion, you should avoid any language-specific constructs. Use the most generic parts so that everyone can understand what is happening. In many languages, you have funky features that only exist in that language, and you can do really weird and strange stuff, but avoid that for this workshop. Questions? This workshop is, of course, also easier to fail for me because, well, the application is not working. Okay, you failed. The diagrams and the code do not correspond. Well, you failed. And you failed on some quality aspect. For example, you used static variables or operations or global variables. Well, you failed. So this is much more of an easier way for examination and actually knowing that you have passed or not. So, or for example, you don't have a model view separation. We find user interface code in the model. Or you have objects connected using keys or IDs instead of associations. Or last year I got one that made a procedural application. It worked, but there were no objects involved, just functions. So this should be an object-oriented design and implementation. So that said, feel free to ask any questions either on the lectures or on Slack, so we can get started as soon as possible with this, and you will have the opportunity also next week for questions and such. So please do start. So last week we did a lot of software architecture. We talked about the model view controller, we talked about layers and components, and we saw, yes, it is okay to have a model view controller separation, as that is one implementation of the model view separation principle. And we talked about layers and components, and we saw the dice game, different implementations, and different qualities that we could achieve by using different approaches. Any questions on that part? Was really, really clear? Or was it confusing? Or was it somewhere in the middle? Probably somewhere in the middle. Anyway, we have covered some notation that I think it is maybe time to repeat or take a look at. And more specifically, we have been looking at class diagrams. For the dice game, we have done a number of class diagrams. And this is basically what we have in this course regarding class diagram notation, at least. So we have the, do you remember the arrows? We have 4 arrows to manage. I will remove the pointer. 4 arrows to manage. Do you know the name of any of them? This one, for example, hold a line and a filled arrowhead. We also had that one in actually the domain model, class diagrams for domain modeling. You could use this arrow also. No, it's not the aggregation. So this is the generalization, specialization relationship. In this case, we also have an abstract class here. And those of you who have eagle eyes can see that this is in italics, so it's abstract. As I said, not the best option maybe. But then we have the more specific class that inherits from the more general class, in this case an abstract class. So this is the generalization specialization arrow. One error you can make is to forget to have this arrowhead, and that will make this arrow very similar to this arrow. And that is not good, because then the diagram changes meaning, because this is, what is this? This one you also used in your domain models. So it is an association. So this is a something that you need to look out for. Make sure you define the correct arrowheads here so that your diagram does not change meaning. One thing you also can spot is that this has a role and a multiplicity. So we have some more information here. And the role name is the same thing as the attribute name when you implement later on. And it is always good to define good role names, of course. Just not say M third class or something like that. Should always strive to say what you actually mean in the roles. So, okay, 4 arrows left. Let's take this one. Any idea? Realization, exactly. Typically used to interfaces. You realize an interface, but you inherit from something more concrete. So inheritance and realization is not the same thing. The mistake you can do here is also to confuse the arrowhead with this one. And this is the fourth kind of relationship we have. And we already have that in the chat here. So this is the dependency. So in implementation, these are in many languages the same thing. In C#, you just say set a colon. If it happens to be an interface that you inherit from, well, then you do a realization in UML. If it happens to be a class that has some implementation in it, well, then it's a generalization specialization you should use. In other languages, you have special constructs for this. I think in PHP you have extends and implements or something like that. So depending on implementation language, this could be somewhat different implementation, but basically it's about inheritance. That's the basic mechanism that is used in implementation. Yes, where are my aggregations and compositions? Typically, don't use them. It is actually just a variation of the association with a little diamond here. But people are really confused about what they mean. So when that situation arrives, well, it is better not to use them at all and just use association. And this is also the advice you will get in the book. So you could have a aggregate for looks like this, a non-filled diamond, and the composition is a filled diamond. But my recommendation is not to use them. Use the association. That will cover you, and you will be safe from any confusion. They can have a good meaning in languages where you, for example, don't have automatic garbage collection and stuff like that. But we won't be going into that really right now. You can read up about them if you would like to. My recommendation is not to use them, as they are special types of associations. So I will be removing that for now. Basically, this is it. And do you remember how the association was implemented? Well, in the implementation, you will be putting an attribute, a member variable, or what you like to call it, in the class. and the type of that attribute will be pointing to, in this case, a third class then, and the name of this attribute will be a role. So if you have an attribute of another type in a class, you have an association between those two classes. And the fourth arrow is the dependency. Do you remember when you can get a dependency? There are 4 quite specific cases, at least. You can get something sent to you in an operation. You can get an object sent to you in an operation. You use that object to do something, but you don't store it in a member variable. So then you get a dependency. You can create objects. You can create an object in a function or operation and use it locally and then throw it away. You get a dependency. You can get an object as a return type. So you ask some other object, could I get all your customers? You get a customer back, and you can use that customer, and then you throw it away. And the fourth one, you could have global variables or static operations in another type. And if you use those, you will get a dependency. So basically, these are the 4 kinds of relations you need to be able to know what they mean and know how to implement them. And you should be able to take a diagram like this and create an implementation, and vice versa. So you should be able to look at an implementation and make a diagram. All right, any questions on this? In many cases, especially when I draw on the smartboard, well, it becomes maybe a little bit more sketchy at some times because it's hard to follow the notation exactly in some cases, especially abstract classes. It's a pain when you do it by hand. No questions? All right, you will be seeing this throughout the rest of the course, I think, so don't hesitate to ask anything if you spot something that is strange, and I will take a look at it. So, okay, let's move on, and we will be looking at the grasp patterns now. And to do that, we introduce a new problem, a new kind of application that we will be doing, and we will be abandoning the dice game, though it was really, really good fun. I think we have done that enough now, so we should move on. And this is the domain model for this new application. Can you guess what it is about? Exactly, it's a blackjack game. Maybe not that surprising if you have looked at the other lectures from last year or the last workshop that is also a blackjack game. But I think this domain model kind of like is at least kind of good at explaining this. So we can see that we have cards and we have a deck that contains 52 cards, so they have a value on the color. So at least with some kind of knowledge, you know that it is ordinary playing cards. We have a dealer, and we can have up to 7 players. And the dealer and the player has a hand with 2 up to many cards when they play. And we have some kind of rules here that the dealer uses and the player knows, hopefully. And the dealer manages up to 6 decks of cards. So as I said, this will also be the last the last workshop, and it will not be exactly maybe like this in the last workshop, but depending on where we end up during the lectures, it will look somewhat familiar to you. So we have a domain model, and of course we need to have some requirements, and we start up with some limitations for our little application here. We will only be using one deck in our variant of the game, mostly because it's easier for us to spot any mistakes. If we see duplicate cards or something like that, we know we have a problem. If we have multiple decks, well, you can get the same cards multiple times, and it will be easier for us to test. We will have quite simple rules. The only thing you can do in our application is hit or stand as a player. There are quite complex things with betting under and splitting and stuff like that in blackjack, but we will be just doing a very basic implementation. We will have one player. We won't have any betting, so we won't be dealing with any money or coins or credits or something like that. We will just kind of like play around. You won, you lost. And we can, of course, check Wikipedia for more detailed rules, and that can always be a fun thing to do. Okay, you can't search like that. So basically, if you're interested in really the details of the game, you can take a look here, and you will get. Well, here you can have hit, stand, double down, split, surrender. So there are more advanced rules to take a look at. And you can take a look at some strategies also if you want to learn how to play blackjack. And card counting and stuff like that. But you can check the rules here. We won't be doing any particular variation, but we will make things up a little bit as we go. But the basic idea is to make a blackjack game. That is a game of 21. And this is the basic rules of it. Have you played blackjack sometime? At least someone nods your heads. So that is a good thing. I have not played blackjack myself for real in, well, quite some time. So it's good to have at least some of you that have played the game. We have some requirements. You should be able to start the game. And when you start the game, the dealer should get a new deck of cards and shuffle them. And we should present some kind of information on how to play the game. Some kind of simple menu or something like that. When we play the game, when we decide to play the game, the dealer deals the cards to the player and the dealer. First, the player gets a card, then the dealer gets a card, then the player, and then the dealer. So we have 2 cards in our respective hands. And then the player can select to hit, and if he does so, the dealer deals him a new card. Or if the player selects to stand or has a total score of over 21, the dealer plays his hand. And finally, the result is presented. And the winner is the one who gets closest to 21, or 21, but not over 21. And you should be able to quit the game. So, okay, we have some requirements and some limitations, and we have a domain model. What is the next step? Basically, this is what you have for workshop number 2. You have a domain model that you did in workshop number 1. You have some requirements for workshop number 2. What should you do next? a class diagram, yeah, you could do that. I actually would prefer it if you selected an architecture first. In our case, it will probably be quite easy. I think we should do it in a model view controller way. We should strive to have a supervising controller variant. That is, the controller conducts how the scenarios are done. And we should make a console application, and we will be doing it in C#. So we have these kind of like overreaching decisions to make first before we can do the detailed design. So the rough order of work is create or update the requirements, create or update the domain model, create or update the architecture, and of course these are only if needed. 4, we do responsibility-driven design of specific scenarios in the requirements. We implement and we test and we deploy. And number 4, 5, and 6 can be in any order. We could do design first, implement later, and then test. Or we could write tests first, do design, and implement. Or we could do code first, test, and do reverse engineering to the design. In my opinion, I don't really care about what order you do these things in, as long as you don't spend too much time on any activity before moving on. So it is not good to spend 4 or 5 days designing before doing any implementation and test work. It is not a good idea to spend 4 or 5 days coding before doing any design or test work. So do a little bit of design, do a little bit of code, do a little bit of testing. Don't spend too much time on any of these activities before moving on. And you repeat step number 4, 5, and 6 until the requirements are fulfilled, more or less. And we will be doing it a little bit by the book. So we will be doing sequence diagrams first, and we will then do a class diagram, and then we will be doing implementation, and then we will go back and check if they correspond. If you prefer to do class diagrams first, that is fine. That is how I learned to do it, so that is more natural to me at least, but the book has a point. I think Larman has a point when he says that when you do class diagrams first, there is a tendency to over-engineer things and add stuff that you really don't need. Doing the sequence diagram first keeps you quite specific to, okay, this is what we are supposed to do right now. So, do you agree to this? You think it's good? So, okay, then let's do this third step here. Let's just create the basic architecture, and you have seen this before, so it should not be a big surprise to you. Here we go. Let's just start a new project, and we will do a console application, and we will name it Jack. We won't be dividing it up into components this time, so we will just add the folders for the respective package. So we will have a model package, a view package, controller package. Basically, that's about it. So, and the next step then is to select the requirement, and well, we need to start the game before we can do anything else, so maybe we should start with this requirement anyway. And the first part is the dealer gets a new deck of cards and shuffles them. So, how should we now continue? We could take a look at the domain model. We don't have a design model to start with, so we need to start from scratch, so to speak. And the first thing is that, okay, the dealer should get a new deck of cards, and so we need a dealer. So, and this is software, so we need to create a dealer object. That is the first thing we need to do. So we do this. I will leave a little bit more room, I think. In UML, this is to create an object is a special message that is named create. When you implement this, you will probably be writing new, but in UML it's called create. And this message is sent to the object box itself, and we don't have a name for this object, which is displayed here, but we have a type for it, a dealer. So someone creates a dealer object. That is what's supposed to happen first. And we add a lifeline to this to show that, okay, the dealer does something. What does the dealer do? Well, he should get a new deck of cards. So let's create the deck then. Once more, we do a create message to the deck. And what should happen in the deck then? Well, we could take a look at the domain model. Well, the deck contains a number of cards, 52 to be precise. And if we check the rules, we could probably see that, okay, we need to have one card for each color and value combination. So we need to create a lot of cards. So we call create, and this time we also add some arguments to this. We have a color and a value. And what we would like to do is make sure we loop this. And we can write this in UML what we mean here. So for every color and value that we have, we should create a new card. And we could even say that we get a card here. We call this C was maybe let's do it. Col there instead. And we could name this object now to C. And then we could do a third thing here is to we don't just need to add the card, we also create the card, we need to kind of like add it also. So let's add it. So this is what happens in the constructor. We loop over every color and value, and we create the card, and we add the card to the deck. And finally, do you remember what the dealer should do? Well, he has opened the new card package, and, well, you can't use them because they are all ordered. So he needs to shuffle them. So afterwards, this is done. They should be shuffled. So something like this should be the sequence diagram for the first step of the first requirement, step A of the first requirement. You can see it as, okay, the dealer actually walks up to the blackjack table, brings out the new deck of cards, opens it up, shuffles the deck, and then you can start playing. There is a step 2 also to present the rules, so we will be talking a little bit about that later. But first we will be taking a short break, and you can, during this break, you can think about, okay, how will a class diagram look based on this? And then we will implement this. So it's a little bit messy to draw these. However, it's really hard to find the tools that support a good UML notation. I have actually not found one yet that is really, really good. There is often something missing, and they are also quite messy to work with and takes a lot of time. So I think hand drawing is a good alternative, at least when doing the modeling. You can, later on, you can maybe do diagrams in a prettier way when you're done. Or you can reverse engineer. You can take a look at the code, and if you have a really good tool, you can just click reverse engineer or generate sequence diagram, and you will have it. Then you often need to go through the process of removing some details because they have a tendency to become really, really detailed. But with good development environment, that should also be possible. So 15 minutes of a break. Think about the class diagram.